Ever wonder how cars are being taught to drive themselves? Well, it's thanks to something called artificial intelligence. And recently there's been an algorithm that has become more and more prevalent, and that algorithm is called a neural network.
Think of the last time one of your friends asked you to hang out. You probably were able to come up with a decision within seconds, but how?
Well, you probably thought of hundreds of factors. What time you need to be there, how nice the weather is, if your parents would even let you go, and on and on. Your brain was able to process all of these factors to produce your final decision. Say the only factors you took into account were who's going to the party. Let's call these your inputs. You assigned each person with an amount of fun points, positive being good and negative being bad. Now, based on if that person was coming or not, you added their fun points to the party's total fun point score. You will only go to the party if the fun point total is positive, because who wants to go to a party that isn't fun? But you have a bias of the party, and you might really want to go, so you give it a starting fun point total of 10. Or you might really not want to go, and you might give it a starting fun point total of negative 10, making it harder for the party to have a positive fun point total. Whether you realize it or not, we just constructed a simple neural network. A neural network consists of three parts: an input layer, a certain number of hidden layers, and an output layer. Each of these layers contains nodes which are individually connected to every node in the next layer. Each of these connections has a weight to it. A weight gets multiplied by the connected node's output value. In our party, a person's attendance was represented by either a 1 for going or a 0 for not going. This was then multiplied by the weight, or their fun points, and added to the total. The nodes in the hidden and output layers each have a bias, which is just a number. These nodes also have something called an activation function. An activation function is a math equation that determines what the node's output value is. The simplest of those is a step function, which is what we used in our party example. A step function will output 0 if the sum of all weighted connections and the bias is negative, and output 1 if it is positive.
You're probably wondering what the hidden layers are since we didn't have them in our party problem. All they do is add extra nodes, which allows our model to recognize deeper patterns. This allows each node to solve a subproblem, which in turn can be delivered to the output node. In a network that plays Super Mario, a hidden node can determine if there is an enemy in front of Mario and deliver that information to the outputs.
When all these connections are working together with proper values, they can solve any problem imaginable. The trouble is, these networks need to be trained, and that requires a massive amount of data. And that's why artificial intelligence has been taking off. Thanks to the internet, we now have access to tons of data that never before has been available. I hope you now realize that computer artificial intelligence isn't magic, but rather just math.